Hey, and welcome to HashiTalks Africa. I actually can't remember how many of these we've done now, which is a great feeling. Welcome, my beautiful people. I'm so glad to be hosting you today for this wonderful event that's going to celebrate our technologists from our beautiful continent. I am your co-host, Rob Barnes. Just call me Rob. And with me, who do I have as my amazing co-host? Ilari, introduce yourself.
Yep, I'm Ilari Adebi. You can call me Ilari as well. And thank you, Rob. It's good to see you again. And it's good to have HashiTalks Africa another year. Just a side note, if any of you have questions or comments, would love for you to interact with us in the chat. As you do, keep in mind the code of conduct in the virtual space. In general, just be welcoming, inclusive, friendly, patient, considerate, respectful, and professional.
Awesome. Thank you so much for that. So we have, I think it's a total of 4 talks for you today for HashiTalks Africa. We're going to kick off very shortly with a talk about Terraform and self-hosted CI/CD tooling. I'm not going to spoil who the speaker is there. And then we've got another talk about using Vault to secure region-specific data management. I'm personally really looking forward to that one there. Our third talk of today is going to be around automating image creation with Packer and VMware Realize. Funny story, I actually went to my first VM World, or they're calling it VM Explore these days, just a few weeks ago in Las Vegas. So I'm really intrigued to see where this talk goes. And we will wrap up with the final talk, which is another one that's just close to my heart, which is secure secrets management. And this is a mix of HashiCorp Vault and Laravel, if anyone's used that framework before. So really packed agenda today. And with that, I think we should probably kick off. So Ilari, who do we have first?
Yeah, let's have our first speaker.
Okay,
so our first speaker is Adefemi Afuwakpe. All right, and he'll be talking on Terraform and self-hosted CI/CD tool. Just a brief bio about Adefemi. Adefemi is an innovative platform engineer with a proven track record of identifying performance issues and making updates to achieve optimal performance. He's adept in collaborating with colleagues to ensure product quality and improvements, committed to achieving state-of-the-art engineered designs and successful completion of projects. With that, we'll be listening to the talk from Adefemi. Welcome.
Welcome.
So hi guys, welcome to HashiTalks Africa. Today I will be speaking on self-hosted CI/CD using Terraform. A quick introduction about me. My name is Adefemi. I think some or most of you are sort of like familiar with my name. I spoke last year and the year before as well. So I'm a DevOps engineer currently working at Swisscom, and you can always find me on Twitter with that info guy. For today, I will just be walking us through 4 different things. One is a quick history. What are the tools that I use, the demo, and also the result as well. So quick history. What brought me to self-hosting my own GitHub Actions runner? The history is I use GitHub Actions a lot. I use GitHub Actions, I use GitLab CI, I use Jenkins, and I've always thought about it. Why can't I host my own GitHub Actions? Why do I have to always rely on the actions given to me by GitHub? Or what if I want to manage what my application is running on? Because with GitHub Actions, right, you run on a particular platform, on a specific platform. So either Ubuntu or a particular version of that Ubuntu, or maybe it's a different type of Linux variant, or maybe Mac OS or Windows. But what if I want to manage every tools that my GitHub Actions is running on? What if I want to manage all the tools? What if I don't want a specific tools, because if you use Ubuntu, for instance, it gives you out of the box of what Ubuntu has. But what if I want something light, like Alpine? Like I want to have an Alpine image, and then I want to make sure when I'm running stuff, I'm the one doing this installation of everything. So I went down the rabbit hole and I started searching. What are the tools out there that does this? And I found two tools, which I will show you now. One of them is this guy. Is from this guy called Myyoung34. Really nice project. And basically, the whole concept is that you run your own GitHub Actions runner in a Docker fashion. You can read more about this from his repository. It's kind of cool. I tried it out. It was awesome. But I wanted more. This was not what I was really looking for. I wanted something much more than this. I wanted something that gives me the flexibility to do whatever I want to do. Then I found this particular tool that is maintained by some people working in GitHub itself. So if you look at the people, right? So the name of the tool is called ARC, Actions Runner Controller. Is a Kubernetes operator that allows you scale and self-host your own runner for GitHub Actions, basically. This sounded cool. This was the perfect thing I needed. And like I said, it is developed and maintained by GitHub Actions team. And also, there are some external maintainers as well, or contributors. So this was the perfect tool I needed. This was the exact tool I was looking for. And then along the line, because with this tool as well, it also has, if you look at the releases, right, it also packages, you can deploy it using Elm, so it also has mchats. And this was exactly what I needed. I needed something that will allow me to use Terraform to deploy it, and then I can manage everything using Terraform. So since this allows me to use mchat, I know Terraform, there's an Elm resource from Terraform that I can use to manage my Elm chats and then deploy my Elm chat. So this was a perfect tool. Now, before you use GitHub Actions runner controller, you need something. You need your token. But one of the good things about this topic is that I've written I've written a blog post in the past, and you can follow this blog post. But this blog post does not use Terraform, which is why I am doing this. This demo for us. This blog post does not use Terraform, basically. So let's go back to our demo, our presentation. So what are the tools I used? So some of the tools you've already seen I've stated in the past. So Kubernetes is part of them. Terraform is part of them to use to manage my my configuration. Elm chart, because this stuff is packaged in Elm. And also, GitHub, basically, because you use GitHub Actions to sort of like run this on the GitHub Actions runner, your CI on the GitHub Actions runner. So let's dive into it. Let's dive into the demo. Before you do this, you will need access token, personal access token, GitHub personal access tokens. In this documentation, I've did a good explanation of how to get your personal access token and what are the specific scope that you need to run this, to deploy GitHub Actions runner controller, basically. So I've done that here, and now let's dive into the Terraform part. So for the Terraform part, at the moment, I only have 3 things that you can run this on. So you can run it on AWS EKS, you can run it on Kind, and you can also run it on Minikube as well. For this demo, I'll be using Minikube. In my blog post, I use Kind, so you can use whatever thing that, as long as you can run the Kubernetes cluster on that particular platform, then you can use it. What else? So like I said, currently it's only supporting AWS EKS specifically. It supports Kind, support Minikube. So my goal is to actually make sure it supports other cloud platforms as well. And like I said, compared to the other projects that I showed you from the other guy, from Myyoung, which is doing Docker in Docker, GitHub Actions runner controller moves much more than just deploying Docker in Docker mode. You can also deploy in the Kubernetes mode as well, which is mind-blowing. It's awesome. So let's dive into it. So I've created some modules, some Terraform modules. So this one is the one, this ArcKTS chart manages the end release for the actions runner controller, but also for the actions runner itself. So we have the controller, and then we have the runner skill sets. The controller is the one having interactions with GitHub and whatnot, and the runner skill set is the one where you are deploying your GitHub actions. Let's put it like that. And then, of course, you have your variables and all. But one interesting thing is this that I figured out while doing this is this dynamic set. This is so cool. And what this means is if you have multiple parameters that are the same concept, then instead of you writing them differently or one after the other, you can use this dynamic set. So cool from Terraform. So, and as you can see, this is the variable basically that I'm passing. And this, like I said, different the variable, if you have a variable that contains name and value, then dynamic set is just best out of the box. So you have a list of objects and the name and value of those list and objects, basically. But also the same configuration is also for Docker and Docker. The only difference between the two is just the mode. So the mode is just a difference, which is why I have two different configurations. But of course, they both have the same concept. I mean, the Docker and the Kubernetes chart have the same concept. For Kubernetes, you need EBS. You need a way to store the. You need a way to attach volume to that Kubernetes controller that is running. So, which is why I have an Actions EBS chart. And like I said, for today, I'll be using Minikube as a demo. So let's jump to our Minikube. So in the Minikube module as well, we have some internal modules in the Minikube configuration. So we have the actions cluster. So basically, Terraform also has a resource, a Minikube resource, and this is provided by this guy, Scott the programmer, also kind of like cool, which is something interesting with the Terraform community, basically. So we have like, I created my Minikube cluster resource here, also like the variables and whatnot. And then, because like I said, you can deploy this in two different modes, Docker in Docker and K8s. But for this particular configuration, I'm using, for this particular demo, I'll be using K8s. So I have to folder the one that is managing the deployment using Docker in Docker, and also the one managing the deployment using Kubernetes. And for this, I'll be using Kubernetes to manage the deployment, basically. And if you come to our Kubernetes folder or folder, yeah, you can see I'm calling the action cluster module, and I'm listing out all this stuff that define in the action cluster module, which is this guy. And if you look at the chart, I'm calling the EBS chart. And the reason why this chart is external is because these three charts, I'm calling them in every tool or every platform. Let me put it like that. So this three chart is being called into every platform in which they will be deployed into. So this is why they are external. And for each and every platform, the way the cluster is being created will be different. And what I mean is, if you look at Minikube, the resource for Minikube is Minikube cluster. If you look at Kind, for example, the resource for Kind is Kind cluster. The same thing for AWS as well, which is EKS. So which is why we have a common modules among all platforms, and each platform have their own internal module in which they are being created. So let's go back to KS to Minikube. So I call the EBS chart, call the arc chart, because I know for this particular one I'm deploying it using KS, so which is why I'm calling the KS chart. And if you go to our variables, variables, these are just empty values. Nothing has been defined. Everything is defined using Terraform.tfs. And yeah, I've set up like the Kubernetes version, the name of my cluster, the driver, Minikube driver. If you check Minikube documentation, you need a particular driver. For this particular one, I'm using Docker, sorry. Set up the amount of CPUs I need, the cluster disk size, the cluster memory, the nodes, also the EBS chart as well. Like I said, there are two different charts that has been needed. So this is the one for the arc system, and there's the arc runners, which is the specific runners, and which is the name. This arc runners is the name that then comes along with when you are creating your GitHub CI YAML file. You will need to use this name, which I will show us. But also, if you remember me talking about this cool dynamic set thing, which I said will contain name and value. So because I know my chart, this my actions are corner chart, I need to make some tweak and some configuration. So some of the tweak are like the GitHub config URL, which I will show us where this is coming from. I created this repository to use for demo. The GitHub token, which this token will be deleted after this demo. The amount of runners I need. So the cool thing about this tool is also you can have a specific amount of runners running at a particular point in time. So you can have like the minimum amount of runners you want. So a particular runner will be available at a point in time. And then you can also have the maximum runners you want. So if, for instance, you are working in a team of 5 engineers, so you know each and every engineer needs maximum of 1 runners each. So you can say the max of runners, you can make it twice. So you can make the max of runners 10. So they won't run out of the 10 runners. And you can make the minimum, maybe 5, because 5 engineers. So depending on your configuration, basically, you can arrange that differently. And also, like I said, the container mode type, which is Kubernetes, but of course, if you're using Docker in Docker, this will be DIND, DIND, Docker in Docker. And also, these are some other configurations that come with setting up the, like I mentioned the other time, the volume claim, the storage class name, the kind of access mode, and the resource, the requested storage, basically, that is being needed. All these are configurations that can be tweaked based on what you want to, how you want to create it in short. So let's jump to it. I'll delete this, and then I'll run minikube delete dash all, because I already created one before now. And this should be fast. Okay, and then I'll just run Terraform. Let's check my history. Terraform apply, auto approve. So of course, this will create a Kubernetes cluster. If I open KNIS, let me see, let me get created. So this will start the cluster creation. Like I said, I'm using Minikube, so it's going to create a new Minikube local cluster for me. Let's go back to the documentation here. So like I said, the repository is online. It's called Terraform GHA. So if you want to contribute, the only difference between what I'm doing and what Actions Runner Controller is doing is that I'm terraforming everything, if that's the word. But yeah, I'm terraforming everything. I'm using Terraform to manage everything that is being done here. And of course, you can manage it. You can do it directly. So in my blog post, I was directly running Elm. I think I do have that configuration somewhere here. Yeah. So I was directly installing this using Elm. But for this particular demo and for this particular repository that I have online, this open source repository, I'm using Terraform for everything. So let's check back. Let's go back to our code. Let's see what the progress is. So it is creating the cluster still. And in the meantime, let me try opening up. So I have a tool that I use to manage my cluster, which is called OpenLens. I think most people should be familiar with it. OpenLens. Yeah. So if I check KNIS, I use OpenLens and KNIS to manage my cluster. As you can see, this is Actions cluster. And if you remember, in our Terraform.tf, the name of the cluster is Action cluster. And you can see it's running the latest version of Kubernetes, which is 1.30. So the nodes are getting prepared. I think that's why this is still running. It's creating the nodes. Yeah, so why it is creating the node, what I can also run us through is some configurations of Arc. Let's go back to this. Let's go back to my blog post. Click on values.yaml. So in my blog post, I really wrote maxed out everything, what is being created, how it is being created. And if you check values.yaml, so like I said, these are the configurations that you see in my Terraform configurations. So if you see this place where I'm passing GitHub config URL. If you wonder where I'm getting it from, I'm getting it from here. GitHub config secret.github token. I'm getting that from here.github token. But of course, you can also deploy this using GitHub app ID, installation and private key. But for me, this is like a long process. But this is if you're doing this in an organization way, this is the most preferred way. So you deploy a particular GitHub app, the installation ID, then the private key of that app, and then you run it that way. This is like the best preferred way. But since this is just running locally in my system, I just decided to use GitHub token. And also, you can set up proxy for this as well. So you can go deeper than what I've done to sort of like set up proxy and to set up proxy this and make it work. So the maximum runner, like I said, is the amount of runner there to scaling will scale up to. So when you set the maximum at 5, that means the runner, you can only have 5 runners running at a time. The minimum runner, so this means the amount of runners that is available at every point in time. So by default, they're setting it to 0. You can also have a runner group. So think of this like if you have a Node application, you have a Java application, and you want to use different runner for them. So you can create different runner group for different application. So different runner group, one for Node, one for running Java, one for running, I don't know, Python, whatever. Depending on your configuration, you can do that as well. You can also attach some sort of certificate to the GitHub runner as well. So it goes, like the configuration go deeper than what I have created with Terraform, but I mean, this is just like a bare bone, like out of the box, get it working, get it running is what I've created. And also the container mode as well. Also the container mode can also like, you can tweak the container mode. So this is typed in, and by default, these are the things that comes with, if you use Docker and Docker by default, it comes with all this by default. But also if you use Kubernetes, which is the second mode, this is the end. This is Kubernetes. So if you use Kubernetes, these are some of the template specification that comes by default with it. But also the runner as well. So by default, it gives you this runner, but of course you can always change this image. This is like it's pulling an image from GitHub registry, but you can always change this image to your own registry. So you can use something like ECR, or you can use directly from Docker. So you can just put Ubuntu here and then it pulls Ubuntu, or you can put Alpine and then it pulls Alpine. So depending on what you want, if you look at my configuration, I am not using not using any image, right? Yeah, in my configuration, so I'm using the default image, so which is the one given by them, and I will show you that as well. So let's see configuration if this is done. So yeah, this has been applied. We have 4 added, 0 change, 0 destroy. And I'm just going to do something quick. I'm going to drag lens to this other screen. It's on my other screen. If I can find my if I can find lens. Okay, sorry guys, I'm trying to look for a lens here. Okay, this should do it. So pods, drop this here. So as you can see, so this is Lens. It's also a tool to help manage your Kubernetes cluster and all. And so like I said, this should be closed. So because I installed some other things alongside the Action Zone controller, this is the action system. This one is the one communicating directly with GitHub and also watching some of the changes. We have metric server. For this, I'm just using it to get metrics. So this is the local PV provision and the storage provision as well. So, and this is the main, we have the listener. So this one is one listening to the configuration that is going on in GitHub. And this is the runner. And if you remember my configuration from Terraform, I said I want minimum of 1 runner. So which is why in Lens, let me put this here, which is why in Lens, you can see that it's just 1 runner that is active at a point in time. And if you look at the configuration of the runner, if we see the image it is using, image, where is it? Yeah. So if you see the image it is using, I told you it's using the default image. So this can be changed. You can put Ubuntu here, whatever image you want to use can of course be changed. But just know that the image you're using, if it doesn't have the tool that is required, then you need to install that particular tool. So how do we test this? Now we have actions running. How do we test it? Before now, I've created a simple application. Basically, what does this application do? Is a mathematics application. So I have 4 different functions that is doing basic arithmetic, so addition, multiplication, subtraction, and division as well. And then I've also written some sort of little test in there that is doing addition, multiplication, subtraction, and I'm using TypeScript to sort of like test this out. Of course, you can use any programming language as long as you're gonna support it. And I've created a GitHub Actions, GitHub workflow. And what this does is, at first, it delays the runner in a particular second. The default is 2, but this is not required. You can use anything for this. You probably don't need this too as well. And then in my job, if you remember, if you are creating a GitHub workflow, when you specify the platform you want it to run on, you either put Ubuntu or your specific operating system. But for this, I'm putting Arc runners. If you remember, I told you the name of this will be the name of your where you want your job to run on. So, which is why in this place I have Arc runners, because when I named the Arc runner namespace, I call it Arc runners. So any name you pass in here will be the name you pass in this runs on. So basically, I'm installing Node, checking out the code, installing Node, running npm CI, and then running npm test. So basic stuff. Now let's go to our code, which is this guy. You remember I told you I will show you the runners, right? That the runners that is being created. So if you are self-hosting your runner, you click on these runners. When you click on runners, you will see the one GitLab is giving to you for free. So this is the one GitLab, I think is the standard GitHub hosted runner. It's the one GitHub is always giving to you. And if you are running on enterprise or something, then you have this one that has 64 cores and this large amount of storage. But if you're self-hosting, you come to the self-hosted runners tab. And as you can see, currently there is one available runner, which is the one I have self-hosted. And these ones, I think they are from the past because I was playing around doing samples just to make sure this stuff work before the demo. Yeah, so these are really actually not available. They are not available. These are just like the runners I've hosted in the past. Because if you see the date as well, it's like in the past. And this is the runner skill set, basically. So this is the one that I've deployed right now that is ready to pick up the job. So let's go to GitHub Actions. I have this workflow here. And then what I will just do is I'll click on Run Workflow. I'll change this to 1 second. And I'll click on Run Workflow. And then we should have a new workflow starting any minute from now, this guy. So, and if you look at, if I click on Test Job, it will go Starting Job. It said it's picking up what? Job is about to start and picking up this runner. If you look at my lens, you see that that runner is this one that is currently available. And if you see the runner P8S, let's see what this runner is called, GCW8S. So GCW8S, this one. So the interesting thing about this is once a runner is done with his job and it is successful with his job, it deletes it. So it deletes that runner and then bring back a new one. As you can see, that runner AWS is gone, and then there's a new one that has just started about a few seconds ago. So there's a new one that started 34 seconds ago. So once it's done with a specific runner, it brings up a new runner, and then that new runner is also ready to pick up a new job. So the wait time is kind of slow. It's kind of little. So you don't have to think of wait time or something. The wait time is little. I mean, you won't notice the wait time. That's just basically what I'm trying to explain. And if you go back to our GitHub Actions that we've just run, you see it runs, it installs Node, runs npm CI, does my test, and all my tests run successfully. And then it just clean up the job. Voila, everything works out of the box. So let's go back to our presentation. So you might want to ask me, yeah, all fine and good, but what is the result? One, you've seen this is cheaper. You don't think of how many actions you're running. You can be running your GitHub Actions runner locally on your system. Also, you can tweak your runner. Like I said, if you want to use a very, very small image, like Alpine or something, you can tweak your runner to use that particular image. Also, think of testing. If you want to test a large suite, you can easily spin off any runner, test your large suite, large test case, and delete it. But don't forget, most of everything that runs on this is ephemeral. What does that mean? That means it deletes after it is done. So if you need a result of something, what our advice is, you can attach a particular volume to your runner and then store all your anything you will need, you store it into the volume and then you can use it later. But if you don't need anything for the volume, you can do it like that. Or you can either push your results to S3 to a particular bucket or a particular storage and then pull it back when it is being needed. I mean, those are some of the compromises that needs to be made. Another good thing is if you run a startup and you ever think of, oh, I spent so much on GitHub Actions, blah, 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 this is something you can just create something in EC2, like run it in EC2, and you only need to figure out how to manage the infrastructure. And Terraform is there for you to manage that. So you don't have to think of, oh, how do I manage this? How do I increase the volume? How do I increase the storage? Terraform is there for you. Yeah. And there comes the end of my talk. So thank you guys so much for listening. I hope this wasn't boring. If you have any question, of course, you can always reach out to me on Twitter. Also, you can always go to the repository, contribute to it if it interests you. Yeah, that's all. Thank you.
Awesome. Thank you for that, Adifemi. Really appreciate you for that talk. Of course, sometimes you want to set up your own CI/CD environment. So that was a good talk. Thank you. Just also to mention that the slides will be available after the conference. So keep an eye out for that. Barnes?
Brilliant. And also we'll try and get those recordings out as soon as we can on YouTube. So yeah, look out for that as well if you want to rewatch that just to take it in a bit deeper. But before we introduce our next speaker, just to let you know that we do have HashiConf coming up in October. The dates are the 14th to the 16th of October. I myself personally will be there. The registration is live. So if you'd like to come and hang out in Boston for HashiConf, make sure you get your ticket as soon as you can. Spaces are limited as always. If you've never been to a HashiConf before, just to kind of paint the picture of what to expect, it's our global event where we bring together our community of developers, IT leaders, engineers, and we get to talk about strategy, infrastructure. We get to talk about the ways that people are deploying our technology. And I don't want to put too much spoilers in there, but my team have been working on some really cool challenges and demos. If you've ever been to a HashiConf before, you've seen some of the amazing stuff we've done. We've done things like built a blockchain using HashiCorp Vault. We've done stuff with Minecraft demos and putting all of our tools inside a Minecraft world, which has been really cool. This year, we're doing something a bit different. And I'm not going to tell you what it is. You've got to be there to see it and experience it yourself. So make sure that you register. For more information, go to hashiconf.com and you can register there as well as view the agenda for the event. With that said, let us introduce our next speaker. We have Amarachi, who's going to give us a talk about Vault for secure region-specific data management. This is specifically around the Pan-African region of the world. The challenges are different for us. So this is going to be a very interesting talk. In Amarachi's own words, I'll give you a quick synopsis of who she is. For over 4 years, I've championed cloud-native solutions through writing, speaking, and community leadership. As a developer advocate for intelligent monitoring tool, Aya, I actively advocate for its capabilities. Additionally, I volunteer my time as a co-organizer of Nigeria's Write the Docs community and serve as the community documentation lead for the Mojo Global, a cloud-native solution dedicated to greenhouse gas emission tracking and estimation. So, great background, great biography, and the talk title sounds amazing. So take it away, Amarachi.
Hi, everybody. My name is Amarachi Hanacho, and today I will be walking you through using Vault for secure region-specific data management. Great. In this call, I will be walking you through what problem is Vault solving, why Vault is important, and how you can use Vault to ensure that your applications comply with established compliance standards, and what features of Vault will help you make sure that your applications are ready to go, and real-world examples of people using Vault in their applications. And we're going to go through a small demo of us implementing Vault for our applications. Great. To start off with, I'd like to start with a simple story, or just so that you understand what is happening. Because of the century we are in, because of how a lot of people are relying on applications, on software, they become more complex, especially in the last couple years. And because they are more complex, they are advised to build these applications in a loosely coupled manner, not monolithic anymore. So you have microservices architectures. So you have applications on different cloud providers, maybe AWS, Azure, spread across different regions, across the globe. And these different applications might be collecting secrets. For example, if you own an e-commerce shop or an e-commerce website, and your e-commerce website is doing, or your e-commerce shop is doing really great, and because of that, you keep scaling up and creating applications on different cloud providers spread across different globes. Your inventory management application is on a different provider. Your authentication application is on a different provider. Your payment gateway is on a different provider. All these different applications that are scattered in different places are collecting important information, are collecting credentials, they're collecting API keys, which they're going to submit to all these payment gateway like Stripe, Paystack. They are collecting OAuth tokens, which they're going to use to sign you in as a Google with your Google account, Facebook account. They have API keys for their inventory management. All these are important keys that you personally would not want to be out there. For example, you would not want your card credentials to be out there. You don't want where you are staying, your house address. But because it's scattered, it makes it very difficult for the organizations to know, okay, who has access to what, right? Are we making sure that our security protocols there are security protocols in place to secure these secrets? For example, okay, we spent so much time securing API keys for the payment gateway or whatnot. Are we going to spend that exact amount of time for different keys that are in different applications? That's just a recipe for disaster. Thirdly, it makes it difficult to know what is happening in your system. It makes it difficult for you to know, for example, who has access to what. And because it's very difficult to know what exactly is happening to your system, it makes it a lot harder for your organization to submit audits or to submit your audit trail to compliance bodies like the GDPR, the NDPR, for them to know that, okay, your application should collect this data. Your application is secure enough to collect this data. And compliance is what we're going to focus on a lot in this call. And failing to meet compliance records or compliance rules comes with very, very hefty price. I don't think even big companies like Google would like to pay. And we're going to get into that more. So what is HashiCorp Vault? HashiCorp Vault is a tool that helps you centralize these secrets. It collects all these secrets in all these places, consolidates it into one platform, and makes it easier for you to encrypt these secrets, encrypt this data. It makes it easier for you to put access controls in place, so you would know who should have access to what and who should not have access to what, because everybody knows that you need to implement least privilege. You don't need to give people more access than they need to do their jobs. And Vault helps you do that really easily. It has features like secret management, dynamic secrets. So it creates secrets that don't live that long. Maybe you need to sign it to your database for a particular period of time. Vault can help you with that. Vault can help you encrypt your data, can help you control who has access to what, max your data or tokenize your data. For example, you probably have seen like credit cards that instead of putting out their full numbers, you have XXX and the numbers. You can do that with Vault. You can rotate your secrets. That means you can create new secrets, revoke those secrets, revoke people's right to those secrets, delete those secrets. A lot easier with Vault. Instead of doing it in one place, going to another place, Vault helps you do that. Vault helps you understand what is happening in your system. It helps you understand who has tampered with what has impacted what because of the audit trail, because it logs what is happening, it logs processes, it logs activities, it logs events, which you can easily submit to these bodies, to these compliance bodies. Also, high availability and disaster recovery. What makes it easier for you to not just lose the secret, even in the event that something bad happens. So let's come to why we're here today. What are compliance rules? I've been talking about compliance rules. What are they? So these are regulations and standards that organizations must adhere to in order to protect sensitive data, uphold privacy rights, and maintain ethical practices in their operation. For example, now we all hear about data. Your data is out there, and you are freely giving this data to organization. A lot of organizations will not even let you use the application if you don't submit some sensitive data. But who is checking this organization? Who is making sure that this organization have the right to collect your data? And it's because of bodies like the GDPR, which is the General Data Protection Regulation, the PCI DSS, the Payment Card Industry Data Security Standard, the HIPAA, the Health Insurance Portability and Accountability Act, the NDPR, which is the Nigeria Data Protection Regulation, the POPIA, which is the Protection of Personal Information Act. Right. So I guess from their names, you probably know what data, what these regulation bodies are watching over. For example, the GDPR, it puts in data protection regulation, data protection laws in place for citizens or people living in the European Union. So the countries that are in the European Union, the GDPR makes sure they care about, make sure that their data are protected. You have the PCI DSS, which is a security standard aimed at protecting credit card information. Where you submit your credit card information, is it safe? You have the HIPAA, which protects health information, sensitive health information. You have the NDPR, which secures personal data for people living in Nigeria. So it's kind of like the GDPR, but for Nigerians. The POPIA also secures sensitive data for people living in South Africa. So, like I said, the GDPR, but for South Africa. So you might be thinking that, okay, why am I getting into this? We're getting there. So in this call, I'm going to be focusing a lot more on GDPR because we could do the same for LDPR, POPIA, but I realized that we don't really have, like for Africans, we don't really have an African body watching over data protection laws for people living in Africa. But GDPR does that for the EU, and they're a lot similar. So if you prepare for the GDPR, you're kind of already prepared for NDPR and POPIA. And they have a lot of similarities. They care about protecting personal data, user rights, accountability. The differences are very probably obvious, right? They all care about people in different areas, like Nigeria, South Africa, and European Union, and they all have enforcement mechanism in place. The GDPR, which I'm going to focus on, has hefty penalties, hefty fines, which is why a lot of people start to care about this. But it's not very easy to ensure that your organization is in line with the GDPR, and that's what Vault helps you with. Like you can see some of these penalties here. Not for non-negligence, you have penalties of 10 million euros or 2% of your revenue. That's a lot. But for negligence, which is probably what you'll be charged with most likely, you have a penalty of 20 million euros and 4% revenue. That's a lot. That's a lot. But what is here to help you? So they have articles, they have like 99 articles that span across different facets of security that you cannot just get with traditional file system encryption. And I'm going to break down some of these articles for you, right? So Article 32 talks about security of processing. I'm going to get into that a lot more. And you can do that using Vault cryptographic barrier and transit. You have feature. You have Article 17, which is the right to erasure, which you can do with Vault transit derived encryption feature. You have Article 26, joint controllers, which you can do with Vault control groups features. You have Article 27, 28, processor rights, which you can do with Vault Sentinel policies and control groups feature. You have Article 44 to 55, transference of data, which you can do with Vault mount filter features. You have Article 39, data protection impact assessment, which you can do with Vault audit, dynamic secret, unified identity, codified vaults, and whatnot. And I'm going to get into that and how you can do that with Vault. So the whole security of processing means that no matter where your data is, whether it's moving, whether it's in transit, whether it's at rest, it should be secured and encrypted as much as possible. And if you remember back then, I told you that Vault helps you encrypt your data. So this is something that Vault will help you with, and makes it very easy for you to do this. And you can do this with the cryptographic barrier and transit engine. And this is available also in the Vault free version, which I'm going to show you how to do. You have the right to erasure. That means if somebody has submitted their data to you, and they're like, okay, I don't want you to have access to this data. They have every right to have their data deleted. And you can do that with Vault transit engine, derive the encryption keys for data. You have joint controllers, which means that, okay, somebody wants to have access to your data. You can implement it in such a way that they only have access if multiple parties agree that these people should have access to this data. You can do that with Vault group control groups features, which is not really in the free version. So you have processor rights, which is a processor cannot engage with other processor subject data without consent, without controller's consent. You can do that with Vault Sentinel policies and control groups, which have fine-grained access control. You have transference of data to third party, which basically says that, okay, this is the data for the EU, for the people living in EU, or for the people in Nigeria, for the people in South Africa. We don't really want this data to move out of the confines of these like borders. And that's really difficult to do. That's very difficult to do, especially in this age, in this digital village age. You can do that with Vault. You can do that with Vault mount filters. Finally, you have the data protection impact assessment, which means that if for whatever reason there is a breach, you should be able to explicitly map what has happened to what has happened to what, the impact of this data breach from different identities. You should be able to map that. And you can do that with Vault audit logs, Vault dynamic secrets, unified identity, codified Vault policies, and whatnot. So with the audit trail, you can watch events that have been happening to your secrets over time. And that's what Vault helps you to do. There are a lot of people that have been using Vault. You have GitHub. GitHub at this point is an ambassador for Vault. You have Nordstorm, you have SAP, you have Adobe, you have eBay, you have a lot of people that care about Vault. Great. So I'm going to kind of walk you through a simple application, a simple Vault use. So that will be the transit engine, which means that you can encrypt your data as much as possible. So here we go. I have signed into my Vault. I have signed into Vault already. So this is my Vault dashboard. So I am going to, I've already unsealed and logged in to where my Vault is installed, and my Vault is installed on a Linux virtual machine. So yes. So of course I just exposed my keys, but those keys are not important because I'm not really using them. So you can create Vault, you can create transit engines on Vault here. It's very easy to do. You can go here, create a new engine, but I'm going to do this through the command line, which is also pretty easy. I have all the codes here. So first of all, you want to enable Vault transit. Okay, I think I know what is happening. Let me open a new window. Hopefully, I'm not run out of time. Okay, great. Now that I've logged in, let me try to encrypt it. So this is how to run it. I have enabled transit. Let me just do it again. Okay, transit is already in use because I have already enabled a transit engine. But run this command to enable a transit and engine. So I'm going to create a new transit key, right? An encryption key, which is going to be called demo key. You can think of demo key as like your password. So I have created a new demo key. Once you're done, I'm going to use this demo key to encrypt a piece of data, just simple data, which is called my secret. So what is happening here is this my secret becomes encoded in base 64, and Vault does that to just ensure uniformity. Then using this demo key that we've created, Vault encrypts this my secret data key. So when you're done, you can see the ciphertext. This is the encrypted information. So you can see it here. For it to decrypt this my secret data, you just replace your ciphertext here. I already did that before, but let me do it again. You already just replaced it here. And just copy it. You get this, which is just the base 64 of our value. Sorry, I already used this before. So let me just copy and paste this. Which is the same value that we tried to encrypt before. This is the same as my secret data, but just encoded in base 64. Then I place it here. And you can see you have my secret data. Because I just decrypted it. So what we did originally here was to encrypt my secret data. All right, once I encrypted it and got the ciphertext, I then used the ciphertext and decrypted it using the ciphertext, and I got the original plain text, but encoded in base 64. I decoded it from base 64, and I got the original my secret data. You can also see, I guess you can also see this. Hopefully, I don't get logged out, which I probably would. I got logged out. Let me log in with I have my keys here. Where are my keys? Oh my goodness, I hope my keys are here. No, let me download this. Let me open my downloaded keys. So you have to log in with your root token. That's what you use your sealed keys to unseal. Use your keys to unseal your vault, because when you install Vault is naturally sealed. I'm going to send you. You can also check. Vault has amazing documentation if you want to figure out how to install Vault. So Vault has amazing documentation. It talks about how to unseal. Okay, not this Vault. HashiCorp Vault. So there's an amazing documentation. You can talk about installing and unsealing. So you can see this transit. This is your transit key here. This is demo key that we created. We can also use this we can also encrypt it here. So we can say, hey there, and encrypt it. This will be your ciphertext. You can copy it, but yeah, we've already done that via the CLI. So the next step we're going to do is, sorry, that's my mistake. Next one we're going to do is so what we just did now is security of process, we just proved that vaults can be used to encrypt and decrypt data. So the next topic we're going to talk about is write-to ratio. How does vault handle write-to ratio? Vault does it in a way that you can use your one, right? You can use ciphertext to provide context to data that you've encrypted. So when you come, okay, I don't want you to have access to my data anymore. What Vault does is Vault just kind of deletes that ciphertext. So your data that's already been encrypted is kind of lost. Nobody can have access again to read that data, no matter what happens, whether breaches or something. Your data is literally useless. Data can also securely delete or re-encrypt to make sure that your previously encrypted data becomes irretrievable, fulfilling the right to be forgotten. So you can do that here. I'm going to show you how to do that a little bit. So I have it here called derived keys. So we can create derived keys the way we sort of created the transit. But here we're going to specify that we want the derived key to be true. So Vault is going to make this key that we are creating, this derived key here, to be a derived key. So what that means is that if Vault is encrypting your data, it doesn't use like a single key. Vault automatically creates keys that are temporary, creates keys for this particular user, for this particular data we're encrypting. So even if this key gets compromised, this automatic key that you created gets compromised, it doesn't compromise all of that data that has been encrypted using this key, using this master key. So how can we encrypt a data? So let's do this. So you have this, we're encrypting user secrets, right? So let me explain this. We're going to first encode this user secret in base 64, then encrypt it using one of the automatically generated keys that Vault will provide. Then we are providing a context, which is user ID 123. We can also call it HashiTalks, anything that we'd like. Oh, no, this is not what I wanted. We can just call it user, to be honest. So we have gotten our ciphertext, sorry. Then, yeah, we're going to replace this with a ciphertext, with our ciphertext. For example, unlike before where we did not need to provide context. If we try to run this without providing context, for example, let me show you. If we try to decipher this without providing context, it's not going to work. I'm going to get an error. You need a context. And you have to do that with derived. So let me show you. Oh, my bad. It's user. So we've got an original byte. We've got an original plain text. So we can always decode it like we did here to get our original data. So user secret, which is what we encrypted originally. I don't know if you can find it. Where is the things that we encrypted originally? Shit. That's what we encrypted originally, user secret. So you can always save this ciphertext or this context in your database, and whenever the user says, okay, I do not need this anymore, you can always easily delete it. And then this data would be lost instead of deleting the original key itself. So yes, like I also said, Vault enables you to have audit trail of whatever is your secrets. And you can do that by enabling audit trail. I've already done that. So I'm going to open my file. So this is what has been happening. Of course, it could be a lot prettier, but yeah, it has your time. what has been happening to what? Yes. So, for example, that's what is happening. This is your audit. So let me clear this up. And like I said before, you can rotate. For example, these are my keys. These are my demo and derived keys that we created. You can always put a bit of rotation on your keys, right? You can edit your keys and say, okay, rotation period. After 30 days, this key would be invalid. We're not going to use this key for anything. I can do that easily with Vault. You can also delete these keys if you'd wanted. And yeah, let me save it. Although I'll delete this after this call. But yes, these are things that Vault helps you with. So yeah, with Vault, you can do a lot of things. You can not just secure your data, you can also ensure that you are following compliance rules. That's very difficult to do, but with Vault, it's a lot easier. And I hope that this talk has not been really boring. I hope you've understood why Vault is so important, and why Vault is such an interesting thing to care about. And yeah, you can play around with it to get a free Vault account, encrypt data, decrypt data, encrypt larger amounts of data from your applications, and do what you like. But yeah, if you'd like to learn more about what is happening in this space, in the cloud native space, please connect with me on LinkedIn, Twitter, LinkedIn. I'm always happy to talk. I'm always happy to chat. Yes, thank you so much. Thank you.
Amazing. Thank you so much, Amarachi. Like I said, when it comes to Vault Talks, that they're really close to my heart, especially when it comes to cryptography. That's one of the subject areas that I'm really, really interested in. You touched on a lot of things that I personally find interesting. You know, we talk about encrypting data in transit and at rest, but how does that actually apply in the practical world? Why are we doing these things? What are the consequences? And it was really nice to kind of see you map the different articles within the GDPR laws to the features within Vault and its transit encryption engine, and how you can make sure you meet the requirements of these laws. So fantastic. I will get a link posted in the chat for more information about the transit secrets engine. You can learn more about deriving keys and convergent encryption. You know, I don't want to talk too much on these things, but you know, I could talk for hours on it because I love it. But yeah, we'll post some links in the chat for you to do a bit more research. And also Amarachi is hanging out in the chat as well, so if you do have any questions for her, please feel free to engage her and share the knowledge. Let's pass it over to you, Larry.
Indeed, that was a great talk. Security cannot be overemphasized. Before we move on to the next speaker, I'll just chip in that you can join the HashiCorp user group or any of them around you. The HashiCorp user group program spans the world in 63 countries with over 50,000 HashiCorp users across 180 chapters. And on the African continent, there are 12 user group chapters. So you can find the one that is closest to you and join. You can visit hashi.co/orgs to find a chapter near you and learn, or you could learn how to start your own as well. We're definitely open for that. So the next speaker, I'll read his profile. His name is Bilal Kalim, and he's a VMware certified instructor, recognized for his exceptional teaching skills, his expertise in VMware technologies. He has been elected for the third consecutive year as one of the top 10 best certified VMware certified instructors. He's a passionate Linux enthusiast. Bilal is dedicated to sharing his knowledge and helping others harness the power of virtualization and automation in their DevOps practices. So Bilal will be speaking to us on automating image creation with Packer and VMware vRealize automation from code push to deployment. Let's have Bilal.
Could you please confirm that you can hear me? Yes, everything is fine. Yes. Just to double check if you can hear me. Yes.
Yes, we can. Yes.
Super. Thank you, sir. So, hello everybody. Welcome to this session titled "Automatic Image Creation with Packer and VMware vRealize automation. Okay, I will use another name in a few minutes, area automation. The name has been changed recently. So in this session, I will guide you through the process, automating image creation using HashiCorp Packer and also a VMware vRealize automation. But the idea is to automate the creation of the image by using Packer. So I will guide you through the process to create an image. But like I say, before diving, it's important to mention that VMware vRealize Automation has recently been renamed to VMware Area Automation. Okay, so this is the new name of the product. Recently, VMware renamed it, and this change aligned with the VMware vision for a broader multi-cloud and hybrid automation strategy. So in this presentation, I will use the updated name. Okay, so what is Packer? Firstly, I want to introduce Packer. Packer is a tool from HashiCorp that allows us to automate the creation of images, and these images can be deployed across multiple platforms like AWS, like VMware. And the beauty of Packer is that it provides a consistent workflow and making it easy to create an image in a repeatable and automated manner. Okay, so with Packer, we can build an identical machine image for different operating system and different environment. Okay, so if generally speaking, I like to introduce Packer like I like to share a story with my student. Imagine you are an IT administrator and you are working in a company. Your team has just been tasked with setting in 20 new server for a major product, and your CEO wants everything up and running by the end of the week. So you start provisioning server manually one by one, and each server needs to be set up exactly with the same way, same operating system, same configuration, same application installed, but with each manual installation, a small difference or a mistake creep in. So you may forget to configure one settings on one server, misplace a password on another. By the time you halfway through, it feels like you are drawing in configuration. So now imagine an alternate scenario. You have a tool like Packer, okay, that can automate the entire process instead of spending hour or even a day manually setting up each server. You write a Packer template once, and this template contains all the necessary instruction for your operating system, for configuration, for your application. So with a push, for example, a push in a Git, Packer can automatically create identical, consistent images across all the 20 server in few minutes instead of days. Okay, so this is the power of automation. And if you use Packer with VMware Area Automation, you will go through another step, because we can create a pipeline, okay, to get the code and trigger creating an image automatically by using the Area Automation. So what is VMware Area Automation? So just speaking, this product is used by many companies. VMware Area Automation, it's like a cloud management platform that allow you to automate a complex IT process like provisioning VMs, provision workload deployment. It's an ideal tool to manage the hybrid and multi-cloud environment, and also VMware Area Automation provide a single point for managing infrastructure across different platforms, because you can connect VMware Area Automation with AWS, Azure, and also Kubernetes, Docker. So different tool can be added to Area Automation, but you need to imagine Area Automation as a single point from where you will manage your infrastructure across a different cloud. in area automation, we have different products. Okay, as you can see here, we have the automation assembler. Okay, we have also consumption. So let's start with the assembler. The assembler is like, this is where you will design your blueprint to deploy VMs in area automation. We have absolutely pipeline. This is what we will use today. Pipeline can help you to automate and orchestrate a process from code to deployment. For example, we have also orchestrator that can provide you more complex scenario to deploy your for example, create DNS record automatically or add user in Active Directory, for example. But today, like I said, the primary part will be focused on VMware Area Automation Pipeline. Okay, this is Packer will use this tool. Okay. Previously, this tool was named CodeStream. Okay, so like I say, the VMware rebrand the vRealize product. So today, vRealize Automation is named Area Automation, and previously CodeStream, now named Pipeline. Okay, so if you find Pipeline, so it's the same thing. This is CodeStream. Okay, so today our goal, please remember, we will use a pipeline to area automation pipeline to create a workflow, okay, to receive, for example, a Git push, okay. When a new commit come in your Git, we will trigger an automatic pipeline to get the code, configure our Packer, and execute Packer to create an image and sync an image with vRealize automation, okay, or area automation, I should say. Okay, so general speaking, we want to show you today a workflow step by step to get the code and create a new image automatically when a Git push comes. So let's discuss the full workflow today. I want to show you the full workflow from pushing code to deploying an image in a vSphere environment in a VMware environment. So like I say, all start when a developer or any of your colleagues do a push in a push code in GitHub. Okay, so this repository, for example, the GitHub contain, for example, the Packer template. So we have our Packer template available in a specific Git repository, and when your colleague do a push in this repository, once the code is pushed automatically in your on-premises data center. So you should have GitLab Enterprise, okay, in your on-premises private data center. And the good news, if you have VMware Area Automation, automatically you can deploy GitLab within Area Automation. So in your on-premises data center, automatically GitLab GitLab will, if you want, mirror the repository and get the code we just push in GitHub. Okay, so this is the role of GitLab in your on-premises data center. So he will get the code in your private data center by mirroring the repository. Then GitLab locally in your private data center will trigger a pipeline in VMware Area Automation Pipeline. Okay, so if you remember, like I told you, we will clone the Git. Okay, then we will start trigger the pipeline. Okay, you can see we have three different stages in this pipeline. We will initiate the creation of the image. We will configure, or I will show you all steps, and finally we will trigger Packer in Docker in few minutes. Okay, so like I say, we will start by getting the code from GitHub, okay? And once you get the code from GitHub, your code is available in GitLab, and GitLab will automatically trigger the pipeline, and pipeline automate, like I say, the image creation process. It will pull all the necessary configuration and all the templates and build the machine image using Packer, and then deploy it as a template in a VMware vSphere cluster, okay? And all this process, like I say, will help you to ensure that each time the code is pushed in GitHub, the image creation and deployment process happen automatically, and like I said previously, consistently. We want to be sure that all that all what the process of the creation of the image is every time the same. Okay, so let me show you. So I will explain step by step, don't worry. Okay, I will go step by step with you. So everything starts, like I say, with the push in GitHub. Okay, the repository contain, like I say, the Packer template, the configuration file. In this example, I will use Rocky Linux, okay, as an example to build an image of Rocky Linux. Okay, so everything related to creating the image, the configuration I want to implement in Rocky Linux, everything is pushed in a repository in GitHub. GitLab is responsible to mirror the repository in our on-premises data center. So any change will be detected by GitLab. Once a change is detected, a webhook trigger a pipeline in area automation, and this workflow ensure that all change are captured and the process is automated end to end, removing any manual intervention. Okay, the next step in the pipeline is the communication between area automation pipeline and our Docker host. In this example, we have a Docker host in our environment, but it can be a Docker cluster, even a Kubernetes cluster if you want. In this case, in this example, I just put a single Docker host, but you can build a Docker cluster or a Kubernetes cluster, and area automation can easily interact with any with the Docker or with the Kubernetes cluster. So, like I say, area automation pipeline will instruct the Docker host to pull a container image from Docker Hub. Okay, hub.docker.com. Once the image is downloaded, the Docker host spins up a container where all our operation take place. Okay, so we will do many action in this Docker host. Okay, please remember this Docker host because we ran many things in this Docker host. Okay, so like I said, once the image is downloaded, the Docker host will spin up a container where all the operation take place. And in the next step, like I said, the pipeline will install a process within a container to allow communication between the container and the area automation pipeline. And this two-way communication is very crucial because it allows us to execute tasks directly inside the container. So once the container is up and running, one of the first tasks is to execute a cloning. So we will clone the Packer repository from GitLab. Okay, we have a container. Now we will get inside the container containing Packer. We will get all the content. Okay, so the repository containing our Packer template file and other configuration we get from GitHub in our private data center in our GitLab enterprise. So here we will get all the information from like Packer template file and other the other configuration. And as part of this process, like I say, the pipeline will securely get the template, replace placeholders for example, root password with the secure and the unique password for each image. We also configure the extra user in Rocky Linux template and set their password. So generally speaking, this is what we want to configure. So everything will be done by Packer container. If I back a few slides ago, you can see it here. We will change the placeholder, create variables. So we are preparing right now all the configuration in the Packer configuration. So once all the necessary data are ready here, once all the necessary data in place are ready, so now we have a kickstart, because it's a Linux, Rocky Linux can be installed automatically. The idea is I don't want to install the VM manually. I want to install the VM automatically by using a technology named Kickstart. And in Linux, we can install an operating system by using Kickstart. We can boot from an ISO file, and by using the Kickstart, we can install the VM automatically. So the idea is we can provide, a Kickstart file and also other configuration file. All this file will be placed in a shared folder. because we will access to this folder after. We will access to the kickstart file, to the configuration file, and all this information are placed in a shared folder accessible by using Nginx. Okay, we use Nginx as a HTTP or a web server, and Kickstart, the new VM created, will reach the Nginx server to get the Kickstart and get all the configuration file to start creating the VM, installing the guest operating system, for example. Okay, so like I say, the Nginx is also running in the Docker host, so everything is running in the Docker host. Okay, now we want, like I say, to create the VM. Okay, so now Packer, okay, will communicate with VMware vCenter. I know it's another product in VMware world, but vCenter, you need to imagine it like the central place from where everything is managed in vSphere environment. So if we want to create a VM, we need an hypervisor. The name of the hypervisor is in VMware is ESXi, and vCenter is like the single point of communication. vCenter will ask the ESXi to create the VM. Okay, so a new VM is provisioned. Packer will communicate with vCenter. vCenter communicate with ESXi to create your VM automatically. Okay, this virtual machine is based on Rocky Linux. Okay, at this point the VM is empty. Okay, so we just create the VM. Okay, and so here we just need to create the VM. The VM is empty. We will assign, so ESXi assign some resource to the VM. You know, it's like how many CPU, how many RAM. So we can configure everything in the configuration file, and we will connect the ISO file of Rocky Linux to this VM. Okay, so we provide the ISO of it's mounted automatically in the ESXi host. Okay, obviously we need to prepare everything in a specific data store in ESXi. So the ISO file should be already uploaded in our hypervisor. Okay, when a VM now powered on, now when the VM powered on, by using the ISO file, the installation will start automatically, obviously. Okay, so Packer insert a boot command into the Rocky Linux installer, which tell the VM where to retrieve. Please remember the kickstart. We create previously the kickstart file that contain all the instruction to install our environment. I can show you the kickstart file, so you can see here. Look at my screen, please. You can see here our kickstart. So it's a very default kickstart that provide all the instruction that should be done manually, but here will be done automatically to install step by step. All the package need to be created, installed, all the configuration that should be done automatically. So this kickstart, like I say, the VM is created, the VM boot, and Packer will show where to get the kickstart that contain all the steps to install automatically the VM. Okay, please remember this kickstart has been stored in a web server that are running as a container in Docker, in the Docker host. Okay, so now the kickstart is automatically downloaded. The installation will trigger automatically. I will show you in a few minutes in my demonstration. So now the VM will, using the DHCP, will contact the Nginx server, like I say, and retrieve the kickstart file. Once the file is provided, we will start installing the operating system. And like I say, once Rocky Linux is fully installed, Packer will monitor. It's important. Okay, we will wait until the operating system is installed automatically and all the configuration is done automatically. Packer will monitor the VM through vCenter to ensure that we obtain finally the final IP address of the VM. Once the VM is ready, Packer will do some post-installation configuration. Okay, so after the installation is completed, the VM will reboot and receive a new DHCP IP address. It's begin also executing any post-installation. If you configure a post-installation script, for example, in my case, let me show you in here. You can see maybe we do some post installation task. Okay, maybe we add some user in sudo to give a super or do any task. You can configure here any advanced task, for example. So we can also update after the installation. We can update the system package. We can execute Cloudinit maybe. Okay, if you want to do some advanced task, we can also execute Cloudinit. We can set up SSH inside the VM, apply a specific key if you want to change the message of the day. So now, once the VM is ready, okay, once all these tasks are completed, after we create the VM, after we install the guest operating system, after we do the post-installation configuration, once all these tasks are completed, Packer send a shutdown command to the VM. After that, we will convert it into a vSphere template. Now we have a template automatically created as a VM, automatically installed, automatically configured. And now when we finish, we shut down the VM and automatically we convert the VM. Okay, we shut down automatically, we convert the VM as a vSphere VM or vSphere template. And this template can now be used to deploy any future Rocky Linux instance. Okay, so as the final step, area automation pipeline will trigger an update in area automation, okay, because we need to ensure that this new template is available for the use within the broader of area automation environment. Okay, at the end of the process, obviously area automation pipeline, like I say, will complete the pipeline and everything will be removed. Okay, so let me just give you a quick demonstration to see all that. So for example, here this is my Packer. Okay, so you can see I have in this demonstration I have three different stage. Okay, so here we are. Generally speaking, we start by so we start everything by GitHub. Okay, so generally speaking, the initiate phase here, we will get everything ready to be. We clone our repo. Okay, so we have also everything configured here. When you select, for example, git clone, you can see. We can clone the repository. It will pull in the input such a Git repository, for example. After that, we will change, okay, everything. We can change, for example, the placeholder in the configuration, okay. Previously, we create here. Sorry, yeah, you can see here we clone our sorry, yes. I want to stop this video here. So we can do the git clone firstly. Okay, so we will get everything from the repo. Okay, from Git repository, obviously, because GitHub will send to the GitLab, and after that we will start replacing the placeholder. As you can see here, we replace all the configuration, maybe password, maybe user, maybe API keys. Okay, and here Vault I think will be very useful because you can see my password. Maybe they are in text clear in area automation. Vault will be very, very helpful here because we can absolutely encrypt or protect our sensitive information. And the next phase, like I say, is to create variable. Okay, so we need to set up some variable, the input variable for Packer, including some of vCenter information, password. I can see it here. So all this is the variable required by Packer. And generally speaking, in the final phase, we update. So here we will build our server, and finally, so you can see here, this is the shared folder. I showed you the shared folder previously that contain the Nginx configuration and all what Packer will do. And the latest one, like I say, we need finally to get an API token and to trigger synchronization with the vCenter to ensure that the new templates created in vCenter are now available in area automation. We also have a pull task that will check every 60 seconds. You will see it in a few seconds. And this one will automatically add our VM or our template in our environment. So, like I showed you previously, this is the configuration. Generally speaking, we need a Rocky Linux JSON file required by Packer. As you can see here, we put some variable, okay, because we can get this variable from area automation automatically. We have also all the configuration where we will find the ISO file, the name of the ISO file, for example. So you can configure Packer to execute some task, like I said previously here in Packer. So we don't need many files. You can see also some scripts to be done after when you trigger Packer. Let's say after we trigger Packer, we can automatically execute some file. Okay. So yeah, you can see here the VM has been created. Okay, so automatically, like I said, the VM is created. The VM is installing operating system and doing some configuration automatically after the VM is deployed without any manual task. This is very, very, very helpful when you have many image to create. You need to have a procedure to follow and automate this process. It will help you to gain time. It will help you also to be sure that all the image has been created with the same way. Okay, this is important to have a standard work. And you can see here the build is doing the job behind the scene. Once the image is created, we will update automatically the array to get the new image from vCenter. Okay. So yes, this is what I want to show you in my demonstration. Generally speaking, like I say, and this the previous talk has inspired me, to be honest. Like I said, like the colleagues say previously, related to Vault. In my use case, the password has been stored in area automation, but I should improve my pipeline very quickly by adding the Vault. I think a critical part of this workflow is securing the credential used through the pipeline. We can, I know we can integrate Vault. Vault can store all sensitive information, including the password they want to use, the API keys, and other secrets. So when a Packer or when automation pipeline needs access to this credential, maybe Vault provide them securely. And this method ensure that no hard-coded credential are ever exposed in our configuration file or repository, and this greatly reducing the security risks. Okay, so as we look to the future, okay, these are several ways we can optimize this workflow. For example, we can also automating the testing or template can ensure that every image built is valid before it's deployed. Okay, maybe we can add the test, because here I'm showing you only 3 phases. If you remember, we build the image, but we should also test the image before we add it to visualize automation or area automation, I should say. Okay. We can also explore more advanced feature in area automation pipeline for further or process and reduce also the overhead. So to conclude, for the conclusion, in summary, we've covered here in this small session how to automate the creation of a machine image using Packer, and with the help of area automation pipeline, we can automate all the process by only one Git push. Okay, so you do a Git push, and we automate the creation, configuration, deployment of an image automatically, efficiently, securely, and consistently across multiple environments. I had now like to open to floor to any question you have maybe. So like I say, I was very happy to introduce this tool. Thank you again, everybody. And yes, we have finished this lecture. Thank you. See you.
Awesome. Thank you very much, Bilal. Automation is one of the principles of DevOps, and Bilal just showed us how to do that with Packer and VMware vRealize automation. So thank you once again. Bilal will be in the chat. If you have any questions, feel free to ask them in the chat and you'll get a response. Awesome. Rob, what do you think?
Yeah, amazing talk. I want to echo everything you said. Big shout out to Bilal. not just a great talk, great delivery, great content. And I like the fact that Bilal was inspired by other talks, which is the whole purpose of events like this, is that we can learn from one another, we can teach one another, we can inspire one another. So for me, just that little comment he made it towards the end is a great success story and kind of justifies everything that we are doing. Right. So moving on, we have reached towards the end of this. We've got one more talk, but before we do that, I just want to remind you all that the talks that we've heard so far and the talk we're about to hear will all be posted in the weeks coming on the YouTube channel. We'll also do our best to post all of the slides from all the speakers as well. I know there have been some issues with being able to see some of the information on the slides, so we'll post all of that as well. So do make sure you're subscribed to the HashiCorp YouTube channel so you can get notifications. And then that way you'll know once we've uploaded the talks onto the YouTube channel, you'll be able to rewatch them, hopefully in a bit better quality, and you'll be able to see it without the blur. And with that, I'm going to introduce our final speaker. Right? And our final speaker is a gentleman named Emeka, who is a results-driven software engineer with years of experience in crafting maintainable web applications. Now, Emeka is going to talk to us today about secure secrets management, leveraging Laravel and HashiCorp Vault. So it'd be interesting to see how he integrates that into the framework. So, Emeka, over to you.
Welcome, everyone. Today we're going to discuss the importance of securing sensitive information in web application. Specifically, we're going to focus on how to protect critical data such as API keys, passwords, encryption keys, maybe any other form of keys or sensitive information you have in your application. The goal is to prevent data breaches and unauthorized access, which are major concerns for any web application. This session will focus on Laravel, a popular PHP framework, and how we can eliminate secrets from Laravel env files by integrating it with HashiCorp Vault to enhance security. But why are we concerned about secrets in Laravel env5? There are many reasons why storing secret in your env5 poses security concern. For example, if you accidentally commit your .env file and make your application Git repository public, or if someone gains access to your application server, the first place they are likely going to look for secret is in the env file. I will demonstrate with a Laravel application that showcases this integration, providing you with practical insights on how to implement your own project. I will show you how to completely store secret in HashiCorp Vault and have a Laravel retrieve and use the secrets without saving them in your system environment variables, Laravel env files. Just a quick little overview on Laravel. Laravel is a highly popular PHP framework used for web application development. It is known for its elegant syntax and powerful features that makes web development a pleasant and creative experience. Some of the core features of Laravel include its elegant syntax, MVC architecture, Laravel eloquent ORM for database interaction, a Bleed templating engine for clean and readable code, and robust security features that help developers build secure applications from ground up. Here is a little overview of HashiCorp Vault. HashiCorp Vault is a powerful tool designed to manage secrets and protect sensitive data. It provides a secure way to store and access secrets such as API keys, passwords, and any form of secret your application uses. Vault helps to ensure that sensitive information is protected and access is tightly controlled. Some of the key features of HashiCorp Vault includes secret management, access control, audit logging, secret listing, and renewal. for the demo, these are some of the few steps we're going to be taking. You're just going to install Laravel, install some packages like Laravel Cell. We also have a package we're going to install that manages the env, allows us to override the env file in Laravel. And also we are going to set up a Docker container for HashiCorp Vault. And Laravel is going to talk to the Laravel and the HashiCorp Vault API using some Laravel packages as well. Take a couple of steps. The first thing I'm going to do is to set up the environment. And in this, I'm going to be installing Laravel. I'm going to set up a Docker container that's going to run Laravel and HashiCorp Vault, and also install some Laravel packages. For this demo, I'm going to install Laravel Filament. Laravel Filament, it's a framework in Laravel that I can use to build admin interface. And this demo, I'm just going to create a simple contact form. And the reason for this is to enable us to demonstrate that this application is able to use secrets from HashiCorp Vault instead of the usual Laravel env. And also we are going to also demonstrate by logging into the Docker container that is running Laravel, and we're going to check in the environment when we switch to HashiCorp Vault, and we'll make sure that those environments are not visible there even when you run print env command in Linux, or even when you try to dump the env global environment. So let's get started. So I'm just going to run this command, Laravel new vault, to create the application. I'm going to use pest, initialize git. So as you know, this might really take time. Setting up the environment takes time. So I'm going to stop the video and I'm going to set up the environment because of time, and I will come back and walk you through everything that I've done in setting up the environment. I'm going to also be writing a script that interacts with HashiCorp Vault, basically Laravel services. And I'm going to also override the Laravel env function. There are so many ways to do this, but I want to override Laravel env function. By doing so, I can implement my own env function by inheriting from the other one, and I'll be able to get the env function to interact with HashiCorp Vault when Laravel requests for environment variables. Right now, we've successfully set up our environment, and what we did, we set up a Docker container, and as you can see in this Docker compose file, which is actually Laravel Cell Docker compose file. This is generated by Laravel. However, we added some entry here for the vault, and as you can see, we had coded this here. Ideally, this should not be here. For example, when you're running these in Kubernetes, there's so many ways to do this to avoid doing something like this, but this is just for demo purpose. So we have successfully set this up, and now I'll be able to access the vault by going to this URL and log in with the vault root password. The next thing I also want to show you is a package that I install, and this is the composer file. And the composer file, composer.json file, I install Filament package, and also install this little package here, and also I added a script here, a helper class. So the reason why I have this here is for it to override the Laravel env function. I'm going to show you that in a bit. I also wrote some scripts that enable me to work with HashiCorp Vault more fluently from Laravel. So I wrote this. This is just a command that pushes the current env file we have here. It pushes that to the vault to avoid just for convenience, instead of going there and typing in all these commands. I can just run the command line, and it's going to do it for me. So I also wrote some scripts, and these scripts are just I call this one secret, and this secret class is the one that talks to the vault, and it makes API call to the vault using the vault address, which is currently in the env file, and also some other stuff. It also has features for caching in case if you want to cache it, and to enable reduce the requests to the vault and speed things up. Okay, and so this is what the override I did on the env. So now that I have this here, I've done some coding here. So here I'm just checking for some of the example. I'm saying here that any secret that starts with this should not be gotten from the vault. It should get it from the Laravel env file. So this represents Laravel env file, and if it doesn't meet any of this, it goes to this function called vault. And what this function does is just calling my secret class, which is this one here. Basically what it does is do some check-ins to know if you should go to vault to get the secret. Like I said, this is generated by Laravel Filament, which is a very powerful framework you can build on top of Laravel that you can use to generate things like this. So I have created an account, and now I can log in. And like I said earlier, it's just a simple demo contact form where you can add contacts. So as you can see, the application works. Next thing we're going to do is to put this secret. If I decide to remove this now, just to show you that it's going to fail. If I remove, let me remove everything here. And if I refresh this page, you can see we get 500. Let me pull it back, and everything should work fine. Okay. The next thing I'm going to do is to put the secret in the vault. So let's go to the vault and create this part of the secret. So the only thing I need to do here, I'm going to create a key value secret on the secret engine, key value, and I'm going to call this demo staging. And this is because I have this here. These are a set of configuration that my script uses to talk to the vault. This part, demo staging, Let's just give it 10 versions and enable this. And that's all I need to do because I have a script that I can use to populate this. What the script is going to do is just to copy all these env files and save them in the vault. So let's run the script. It's going to run cell artisan vault demo MC. So it says the environment has been successfully pushed to vault server. So let's check it out. So we do a refresh here, and because for security reason it does this, because it doesn't save your password in the browser. So now we're in. You can see it has created this for me, and you can see all the secrets here. Here. And at this point, our application still works, still talks to the database. And what we're going to do is going to get rid of everything except our configuration. And when we go back, application, and refresh it, let's log in back. As you can see, we're still able to log in the application. And as you can see, there is no env file. And in this env file, there's no secrets here. Though we have this here, and that's where the advanced features of Vault comes into play, where you can rotate secrets and do all sort of things just to make sure that you're not exposing those secrets. One other thing I also want to show you is that those env in the environment are no longer there as well. And also, you cannot find those env files when you try to dump the env global variable. So we're going to go into, run print env. So as you can see, when you run this command, print env command, you can see here that those env values are not here. We're also going to try checking the env global variables. We can investigate this using Laravel PHP Artisan. Laravel PHP Artisan Tinker, and we can just dump the variable. As you can see here, all those database passwords are no longer here. All these are coming from the Docker Compose file. So this is quite interesting that Laravel is able to still keep working, and Laravel doesn't even know that it's getting those env values from the HashiCorp vault. Thank you for being part of our demo. In summary, secure secret management is crucial for any Laravel application or any application. By leveraging HashiCorp Vault, we can enhance the security of applications and ensure that sensitive data is protected. Using Vault with Laravel provides centralized secret management, secure storage, and automated secret rotation, making it an ideal solution for managing sensitive information. The practical demonstration shows how easy it is to integrate with Vault with Laravel, securely store and retrieve secrets, and implement best practices for secret management. I encourage you to start leveraging Laravel and HashiCorp Vault in your projects to enhance security of your sensitive data. Thank you for your attention, and now I am open for any questions you may have, and thank you for attending. If you have further questions or would like to connect, you can reach me via my contacts. I've also provided a link to the demo and GitHub, and where you can actually clone it and just play around with it.
Thank you so much, Emeka. It's really great to actually see the practical use cases for some of our tools. The amount of times I've seen talks where people showcase the power of Vault, and it is an extremely powerful tool, but it doesn't speak directly to the developers. It's speaking to a different audience. So actually, to speak to developers and say this is how you can leverage HashiCorp Vault within your applications at runtime, it's really great. And also, as someone who predominantly develops in Go, I'm very jealous of the ecosystem framework of Laravel. Just like I'm jealous of Spring and .NET, this is more than just a language; it's a complete ecosystem. So yeah, great job, Emeka, and thank you so much for taking the time to share your wisdom with us. Quickly, I want to just remind you all again. I said it before; I'll say it again. We have HashiConf happening next month, just a few weeks away. It's in Boston, 14th to the 16th of October. Head over to hashiconf.com to find out a bit more and register your interest, because tickets will sell out very fast. It's always a great event. Come and hang out with the community. Come and learn from one another, just like we're doing at this event, but we can do this in person with more people. So yeah, definitely check that out. So we've reached the end. Larry, what are your thoughts on the event so far?
Yeah, it's been an excellent one indeed. Thankfully, the demo gods, did well this time around. And, I'd like to appreciate all of the speakers. I did learn. I'm going to definitely go back to the Vault talks, because even at the organization where I work, we're, beginning to do some things with Vault, even though I'm a beginner in that, but I see these talks would definitely help to speed up and ramp up on things. But it's been an excellent one so far. I hope to see more Africans, get to do talks like this, and HashiTalks is an opportunity for them, so it's been wonderful having everyone. Till next year. What are your final thoughts as well?
Absolutely. I'll echo what you said about the demo gods being on our side. I must admit, I had to sacrifice a keyboard in order for the demo gods to give us some mercy. But yeah, no, it was great to see it all come together really nicely. Someone who's more security focused as well, a lot of the times at conferences and events, the things that I'm interested in don't get as much shine. So it was great to see that, Vault rules the world, But yeah, I mean, before I wrap up, I just want to say a huge thank you to all the speakers, not just for giving a talk, but all the time it takes, to give a talk. As a developer advocate, we kind of have a rule of thumb that, it takes an hour per minute of a talk in terms of preparation. So if you have a 30-minute talk, it normally takes about 30 hours to prepare that talk, between building the demos, the slides, the flow of the story. So they do invest a lot of time into this, and I'm eternally grateful for that, and sharing that with the community. Also, behind the scenes as well, there's a lot of people at HashiCorp that make things like this happen. I'll give a personal shout out to the big homie, Jasmine. Thank you so much for organizing this and all the hard work you put in the background, and also your bestie, Alexandra, and there's so many other people that I can't go through the whole list, but seriously, there's a lot of work that goes in the background to make all of this happen. And speaking on behalf of the community, I want to say big thank you to all your efforts, and finally to you, Ilari, for joining me again. We're making a habit of this. Let's continue. It's always great. Always great to catch up with you. Always great to catch up with you. And with that, we have reached the end. It's always a sad time when we reach the end, but we have more to look forward to. We'll hopefully be doing this again next year. We also have more regional events planned throughout the next 12 months as well. So just make sure you're locked into all of our social media channels. Make sure you're locked into our YouTube channel, and you will find out more. And thank you so much to you, the audience, for actually hanging out with us for this last few hours. It's been great to, hang with you, share these talks, discuss some of the things we've learned with Illyri. So thank you for giving us your time and trusting us to share knowledge. And with that, I'll say peace out and goodbye.
Bye.
Thank you.